All right, so again, those abbreviations that we just said, cosine was adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Now, the reason we're not going to use those that much right now is because it actually helps us on a coordinate system to refer to stuff as x's and y's. So we're going to translate what we just talked about into an xy system here. If I had any angle kind of around that unit circle or the circular xy coordinate plane that we're talking about here, I can make any angle into a triangle. So you see the angle theta drawn in here. If I just kind of drop down right there, perpendicular, this is going to give me a triangle formed with that angle. And that angle that we're going to use, and you're going to see this today, is always going to be a reference angle. It's always going to be with the x-axis. So that's why I said reference angles, super important. We're going to use them for the rest of this chapter. Now, what they have told me here is that this angle goes through a generic point, xy, any xy point on the coordinate plane. What does that do for me? Well, it allows me to label the sides of my triangle. If we're on the coordinate plane, the x is how far we go out side to side, and the y is how far we go up and down, right? So which side can I label x? The right or the bottom? The bottom. That's my x distance. My up and down distance on the side over here is going to be labeled y. And now there is a reason that the hypotenuse we've labeled r. Because technically if you went around the circle, okay, it is a circle. Where does r come from? Radius, right? So if you go around a circle, that's where that r, the radius, comes from. Now, using your sine, cosine, tangent definitions that you're a little bit more familiar with, let's set up sine, cosine, tangent using these letters. So if sine, we know, is the opposite side from the angle over the hypotenuse, okay, what's the opposite side in my picture? Y over, what's the hypotenuse? R. Cosine. We're going to use adjacent over hypotenuse. The adjacent in my picture is x over r, right? And tangent is going to be what? Okay, opposite is y over x. I am going to refer from here on out as much as possible because for me, the sine, cosine, tangent, being SOHCAHTOA, it's kind of like natural to me too. That's how I was taught that. It is easier in what we're doing today to refer to them as X, Y's, and R's, okay? And it will be for this semester, so the more we get kind of comfortable with that, the better. And these are the definitions that are going to go down in that box below, okay? So we're all typically slightly familiar with sine, cosine, tangent, okay? Anyone see those other three before? They're not the negative ones, because that we're going to also talk about. The negative ones are called inverses. We'll talk about that later. These are what we call reciprocals. We've seen the word reciprocal before. Okay? They're the reciprocal functions, and a reciprocal just means that you take a fraction and do what with it? Flip it. Okay, so what that means for me, okay, once I have these three definitions written down, is that the reciprocal identities that are across from each of these are literally just flipped fractions. So cosecant goes with sine. That means when I write the definition for cosecant, I make it cosecant of the angle is equal to the reciprocal of sine, which means it's what? R over y. Secant is the reciprocal of cosine, which means it's what? R over x. And cotangent, or COT, is the reciprocal of tangent. X over y. Okay? Just for kind of a memory purpose, it will be important that you know which one goes with which. I'm not going to be giving you these definitions. Okay? You'll kind of know sine, cosine, tangent, and their ratios there. And then you will need to know which one goes with which. The tangent and the cotangent should kind of be obvious, hopefully. They both have the word tangent in them. The other four, here's how I remember, and it's up to you. It's stupid, but it works for me. They cannot start with the same letter, the pairs. So sine has to go with cosecant. Cosine has to go with secant. So for me, that I just keep that straight in my head. I can't put the two letters that go together, that start with the same letter. Again, dumb memory device, but it works. So we are going to use these definitions just to kind of practice setting up some basic ratios. So if you need to flip back to that here and there, feel free, but flip to the back. We're going to do 2 examples with this. Okay. Some of the example here, we're just going to talk through the language of what it says. It tells me the terminal side of theta in standard position. Okay, remember standard position starts on the positive x-axis, goes clockwise. Okay, it passes through the point P that is given to us. My point P is 6, 8. What quadrant is that in? 1. That matters because that tells me where am I going to draw my angle. Quadrant 1. Where is my triangle? Quadrant 1. Okay, these things matter. So I'm going to start with drawing. Here's my initial side. Terminal side falls in quadrant 1 somewhere here. Can I make a right triangle from this if I make it using the reference angle here? Yes. I can drop this down right here. Okay, remember that sine, cosine, tangent can only be used in right triangles, so that actually matters that that's a right angle. What does the point 6, 8 do for us? Because it goes through that point. Okay, it tells me the bottom is 6. The y, the side over here, is 8. Uh-oh, we're a little bit stuck. Why? We don't have r. Okay, how do you find it? Pythagorean theorem, like the only thing from geometry that I ever ask you to remember. Now, also, this one you actually don't have to do any math for if you remember that there were things called Pythagorean triples. One of them was 6, 8, 10. Good. If you don't remember it, it's very, very quick to do 6 squared plus 8 squared equals r squared and solve that for r, right? Now, once we have our triangle set up, we can set up the 6 trig functions of theta. I set mine up in a very specific order to help me remember which ones go with them. So my setup kind of gives me a good chance at success. We know that we typically go through sine, cosine, and tangent first, and then I immediately set up my reciprocals across from them. So quick memory, sine goes with which one? Cosecant. Cosine goes with secant, and tangent goes with cotangent. Okay, using our new definitions, sine, try not to think of it as opposite over hypotenuse, even though that's the immediate way you want to. It's your x over, or your y over your r, right? So y is what? 8. R is always reduce 4/5, which immediately tells me cosecant is what? 5 over 4. Okay, take a minute in your little tables or by yourself, either way, and see if you can finish out the other 4. All right, any issues so far with setting up our sine, cosine, tangent values here? Just fractions, they're ratios. All right, let's take a look at the next one. The next one does have a square root in it. It doesn't really monkey with the answers too much. It just requires you to do a little bit of math on the way. First off, the point that I am given is what? -4, which takes us to the, okay, over to the left, -4 up, √2, okay? Now, keep in mind the terminal side of my angle goes through there, so that means that we're going to start here, draw around to somewhere in here, okay? And it goes through this point. Now, when we draw our triangle, it is always to be used with a reference angle, okay? So that means that when my triangle is drawn, I drop this down to the x-axis, and I'm using the triangle down there, even though I've drawn the angle around to that place, okay? Where does the -4 go? At the bottom. The √2 goes on the side. Now, this is not one that you would know the hypotenuse to, so you do have to do a little bit of math to get there, okay? -4 squared plus √2 squared equals r squared. What happens when you square a square root? Just the number. Yep. So 16 plus 2. I'm not going to make you do a ton of stuff with radicals. You'll see that in this particular problem. But I do expect you to be able to say 16 plus 2 is 18. And when I square root, what does that simplify to? 3 root 2. Right? Yes. That will matter because it will reduce in this problem. And if you don't do it, your answers are not going to reduce properly. So things that I will expect you to do, I'll start you off on a couple of them here. Okay. Sine is equal to the y over the r. What's the y? Root 2 over, what's the r? 3 root 2. What happens to my root 2's? Cancel. Okay, so that is something I expect you to be able to do. But that is, to me, that's nothing to do with the square root. That's a reducing a fraction. Okay? Cosine, if I set that one up, the x is what? Negative 4 over 3 root 2. This is fine. Does anything reduce? No, you do not have to do what we call rationalizing the denominator, which means multiplying by root 2 over root 2 to simplify it and not have a root on the bottom. I don't care about that. I do expect you to reduce fractions, though. See if you can finish out the rest of them from here, setting up the 3 reciprocals with them as well. All right, once you check these, we are going to flip to the next page and talk about what we call special angles. We are going to come back to the following page that has questions 3 and 4. It's just a little bit more in depth than I want to go today. So we're going to come back to that. Keep flipping. If we skip 3 and 4 here on the following page. All right. Okay. All right, so here's where life gets like super important for today. All right? We briefly talked about the unit circle last class. The unit circle was the one that we kind of filled in all the angles on. Okay, these are what we call our special trig angles. It sounds like we're making it more important than it needs to be, just calling them special. But do you remember back when you learned square roots? Your teacher said we're not going to learn every square root because they're not all nice, right? But we're going to learn what's the square root of 4. We all know that, right? We're going to learn what's the square root of 9. Those are what we call like the special square roots, but you wouldn't really have called them special then. They're the perfect square roots, right? That's the kind of ones we talked about. That's what these are for trig, okay? These particular angles that show up in the unit circle, 0, 30, 45, 60, 90, and so on around the circle, these are the ones that you can find your sine, cosine, tangent values without using a calculator. Just like a square root of 9 you can find without using your calculator. But in order to know like why or what these numbers are, we are going to briefly refer back to geometry. Briefly. Okay. In geometry, do we have a vague recollection that you had 2 things that were called special right triangles? 30, 60, 90, 45, 45, 90. I do not expect you to know what the sides were. Just a vague recollection that those existed. Yes? Maybe? Okay. We are going to use those, and that is really where our special angles come from.
Upper school party interruption. At this time, we need our cheerleaders.
All right, so that's where our special angles come from in our unit circle. Because if you think about the first quadrant, it's 0 degrees, which is obviously a very special case. But then we go to 30 degrees, 45 degrees, and 60 degrees. All of those appear in a special right triangle somewhere, right? So that's where all of these are coming from. Again, I don't expect you to remember like what the ratios were of the sides, but know when I write down the sides, that's where I'm getting them from, geometry, okay? So let's take a look for a minute at the 45 degree one. We're going to start with that one. If we drop down that side, just like we did on the previous page, we make a triangle. In geometry, at some point in life, you remember or you learned, you may not remember, that the 2 legs on a 45, 45, 90 triangle were the same, and the hypotenuse was a multiple of that, okay? What they were in particular, now we're in the unit circle, and the one thing that matters from the very top that we're going to come back to here is that the unit circle, every single angle in the unit circle has a radius of what? Anyone see that up there? 1. Okay. So all of these are going to have a radius of 1. Every single one, because that's how the unit circle is defined. Basically, we're doing a simplified version of this on purpose, okay? So in the unit circle, our radius is 1. And the 45, 45, 90 triangle had these two sides that were exactly the same as each other, okay? You may have had a different version in geometry that the hypotenuse was 2 and the sides were root 2. That might have been more familiar to you. But that's where those are coming from. So from that, knowing that, I can set up my sine, cosine, tangent of this angle using these sides. If my angle is 45 degrees, sine is defined as the y over the r. What's the y here? The root 2 over 2. What's the r? 1. So do I really have to divide those? Nope. So there's my sine value. What about cosine? Same thing. And how do you find the secant and the cosecant? Flip them. Tangent is defined as the y over the x. No matter whether those are nasty fractions or not, if you divide two things that are the same, what do you get? 1. And what's the reciprocal of 1? 1. Okay, so these are values that we are going to get comfortable with. All right? Right now, they mean nothing to you. But when we build our chart here in a moment, these are going to come back. Okay? Next page. Let's talk about the second special right triangle. We have a 30-degree one. Okay? And the reason we started with 45 is because there's only one of those, where the other one we have two 30, 60, 90 triangles. They're just flipped different ways. The 30, 60, 90 triangle rules using a hypotenuse of 1 or a radius of 1, because we're still in the unit circle. The short side was half of the hypotenuse, and the long side was root 3 times the short side. So root 3 over 2. Using that same thing, I can find the sine of 6 or the sine of 30. Okay, the y over the r in this case would tell me the sine is what? 1/2. Cosine x over r is what? Root 3 over 2. Flip those for their reciprocals. And I'm going to show you something for tangent. Tangent is y over r. Technically speaking, when you have double fractions, what's kind of your procedure? Keep the first one and do what with the second one? Flip it and multiply. What happens to the 2's? Cancel. So what would be my tangent? 1 over root 3. Now, we're going to do quite a bit of this kind of thing. So there's a shortcut to this. You know how we say on a fraction, top and bottom, if something's the same, it cancels out? Okay, well, that works in double fractions too. Look, the denominator's the same. It cancels out. What are you left with? 1 over root 3. Okay, shortcut if you ever need it. Cotangent, all you have to do is flip that. If I flip it, what does it make? Square root of 3. Now, when we do the 60-degree one, you're going to see a lot of very similar answers, because why? This first one was a 30, 60, 90 triangle. The second one is also a 30, 60, 90 triangle. It's just flipped. Okay, we're just looking at the 60-degree angle instead. So let's take a quick look at that. And then we are going to work with some of the quadrant ones real quick. Okay. Again, radius of 1. Short side is half of the hypotenuse. Long side is that. Take a minute, try to fill in those values using what we have just done. All right, so for the quadrant angles we have going on here, you can also find sine, cosine, tangent values for those. However, here's the tricky part of this. Can you really make a triangle at 0? Okay? If you can't make a triangle, some of you struggle because you're still trying to do the opposite over the hypotenuse, the adjacent over the hypotenuse, and so on. But let's do 0 all together for an example, and then I'll let you with your partners or people around you do some of the other ones. I'm going to set up all 6 for 0. And just for reference, we're going to do 0, 90, 180, 270. We will not do 360. Any guesses as to why? It's the same as 0. Okay. All right, so setting these up. If you are still thinking about this, notice I drew the coordinate plane in here, the XY coordinate plane. To get to 0, let me draw a point in here. Not that color. All right, if I want to get to this point where 0 degrees is, going out that direction, okay? Keeping in mind the unit circle has a radius of 1. To get to that purple point I've drawn there, how far am I going to the right? 1. How far am I going up and down? 0, because it's a point on the x-axis. And what's the radius for every single one of these? 1. So this is my x, this is my y, that's my r. Can I find sine, cosine, tangent using x, y, and r? Yes, I don't have to have a triangle. Okay? So let's look at sine. Sine is defined as y over r. Well, that purple point right there, what's the y? 0. What's the r? 1. What's that going to give me? 0. Cosine at 0 is x over r. What's the x value? 1 over the r value. Okay, what does that give me for the cosine? 1. Tangent is y over x. What's y? 0. What's x? 1. What's that give me for my tangent? 0. Now, I wrote those there not because I think you can't divide 0 by 1, but because of the reciprocals. Okay? When you go to do cosecant and you flip the fraction, you are flipping 0 over 1. What does that mean the reciprocal of 0 is? Undefined. You may use 0 with a slash through it, or you may use UND. Either one is okay. Reciprocal of 1, you're literally flipping 1 over 1. Okay, what does that give me? 1. Reciprocal of 0 over 1 is again? Okay. Now, what I would like for you to do is take a minute, or a couple minutes really, and we're going to do that exact same process for 90, 180, and 270. But before we do, let's talk about the points for each of them, okay? Because remember, this is still x, y. To get to 90, to go this direction, there's a point right here. Okay, what is that point going to be? How far do I go side to side? 0. And then I go up, what? 1. So for 90, I'm going to use the point x is 0, y is 1, r is still 1. To get to 180, I have to go to the left over here to get to that point. To get to 180, I'm going to go left how many? Okay, -1. Up and down, 0. So I'm going to use that x and that y for 180. Okay, and then for 270, okay, to get down to 270, to get to this point right here, I'm going to use what x and what y? Side to side, 0, down, -1. Okay, does that help you kind of get started with your x's and y's and r's? Do not try to think of those as triangles because you can't. Shockingly, these are the easiest numbers wise, but the hardest for y'all to think of because they're not triangles. Okay? So take a minute with the people around you or by yourself if you feel like it. I'm going to put up answers myself. As you are checking these, something that will be important for you to keep in mind going forward, I want to point out 2 definitions real quick that we talked about. We said sine was defined as y over r, and cosine was defined as x over r, right? What did we say r was for the unit circle? 1. So what is really sine defined as? Y. And cosine is defined as x, okay? Notice how that kind of worked out for those points. If you go through every single one of those, the sine is the y value at that point. The cosine is the x value. What this really matters for is signs, and I don't mean S-I-N, I mean S-I-G-N, the positives and negatives. This is why I'm really pushing the XY coordinate plane, okay? Because when I ask you what is the cosine at 180, The most missed question is that one because you will just tell me 1 and not -1. It's a stupid number. It's very easy. It's 1 or -1, but it's the sign that you will miss. Because when we get to doing this stuff, and I'll kind of tell you a bunch of stuff ahead of time, I'm a big partial credit person. You know that. But a page of these kind of questions, there's no partial credit. You get the answer or you do not. That is it. And if you put 1 and it's -1, I'm not even giving partial credit for negatives. You got to know the negatives. That will be like a big important thing. So thinking of your sine as associated with the y values and your cosine as associated with the x's will help you keep the signs straight, including the other parts of the quadrants, not just these. Okay, because if you're thinking you're in quadrant 2, the x's should be negative, the y's should be positive, which means my cosine should be negative, my sine should be positive. So it will help you keep the signs straight for the rest of this time if you remember that sine goes with y, cosine with x. Now, the very last thing we are doing today is this chart. Okay, this chart is literally the quiz I am handing you next class. This chart is not what we forget after one quiz. Like this chart you need for the remainder of the semester. And I say that, and still in May every year people are like, you really meant that. Yes, I did. It is important for the rest of the year. Okay? Now, where does this chart come from? Well, all the work we just did. So I want you to grab your chart, and you're going to need a mixture of this page we just did with the 0, 90, all of that, and page 22 and 23. Okay? I got to find my chart here. Okay, we are going to start with just filling in the degrees and radians at the very top of your chart. Okay, so at the top in this first column, or the first row, we are only filling this out for quadrant 1. So the degrees going from 0, 30, 45, 60, and 90. And their corresponding radians. Okay? So this, if you're remembering the unit circle we did last class, these are the 5 things that were in the unit circle first quadrant. 0, 35, 30, 45, 60, 90. Corresponding radians. Hopefully you know at least 2 of them at this point. How many radians is 0 degrees? 0. How many radians is 90? Pi over 2. Okay? Just like 45 is halfway to 90, the radian that goes with it is half of pi over 2, which is what? Pi over 4. Okay? And then the rest of them are fractions that go forward. 30 is the same as pi over 6, and 60 is the same as pi over 3. If it helps you, you can think the denominators are the same numbers, but flipped. Okay? The 30 is not going to go with the pi over 3. Okay? All right, so far, yes, those 5 blocks are memorization, okay? Now, if I want to fill in the rest of them, this is where we're going to look at a combination of page 18 and page 22 and 23. If I want to know what is the sign at 0, well, we just did that. Go back and look at page 18. What was the sign value at 0? 0. What was the sign value at 90? I'll skip because that's on the same page. 1. So my sign values go from 0 to 1, and they progress getting larger every time. To find the sign at 30 degrees, I look at page 23, I think. Page 23, what did we say the sign at 30 was? 1/2. On page 22, what did we say the sign at 45 was? Root 2 over 2, and the sign at 60? Root 3 over 2. Now, here's where I'm going to pause for a moment, okay? Yes, if I actually look at this page as all memorization of every single block, that's what, like 20 blocks maybe, okay? But so far, really, we have maximum of 10 right here, okay? And if you learn this correctly, you don't have to memorize one more thing on this page, okay? Sine runs from 0 to 1. Okay, let me show you a quick pattern here. This is not the cosine values. I'm just writing something down. Is there kind of a pattern right there? Yeah. And what happens if I reduce each and every one of those? What's the square root of 0? 0. 0 divided by 2 gives me? 0. What's the square root of 1? 1. 1 over 2? Can't reduce square root of 2 over 2. Can't reduce square root of 3 over 2. What's the square root of 4? 2. 2 over 2 is? 1. All right. So nice, easy pattern if you don't want to memorize the sign values. And then here's the rest of this. Nice and easy. Cosine values flip from the sine values. Instead of going 0 to 1, they go 1 to 0, and they flip order. They go down in order rather than up in order. Okay? So no memorization for cosine, if you know sine. No memorization for tangent, and here is why. Okay? Remember I told you earlier, tangent was defined as y over x. What did we say y was associated with? Sine. What did we say x is associated with? Cosine. Oh, why might I bring that up right now? Look how I have set up the chart. Sine divided by cosine gives me tangent. 0 divided by 1 gives me 0. And remember how earlier I pointed out if you divide two fractions, the denominators cancel out and it just gives me the two things. So what is my tangent at 30? 1 over root 3. Okay? Two numbers divided that are the same are just 1. Ignore the denominators here and it gives me root 3. And 1 divided by 0 gives me what? Undefined. Okay? All right. So with lots of patterns there, max memorization is actually 10 blocks only. Okay? That is the exact quiz I am giving you next class. I'm adding nothing to this. And for future reference, any test that requires this has a cover sheet on the front that is that chart and a blank unit circle if it makes you happy. Okay? So I copy it on purpose, set up so that you can rip it off, stick it next to your test, and use it. So it's not like you're not going to have a copy of this on a test. You just have to fill it in. Right? So knowing it is good for you for all of the future. Yes? Okay? Now, let me show you homework real quick. If you would like an extra copy of this chart to take home, I'm going to stick my stack in the back. This is something that I just kind of keep copies of around, period, all the time. So if you would like an extra copy to practice at home, you are welcome to do that. But it's pretty easy to draw your own. Okay? Homework is pretty short and sweet. Page 25 only on this. We're not going to go into 26, so it's just questions 1 through 4 like the first two we did. Now, I want to look at page 27 with you. It looks like a ton of questions, okay? This, at the most, should take you maybe 5 minutes. Why? Because of this chart. Question 1 asks sine of 60. Where do I go look for that? Go to 60. What is the sign there? Square root of 3 over 2. Okay, tangent at pi over 4. You look at your chart, find that, okay? Right now, this is practice using the chart, okay? The only way you get this page wrong is if you go find a calculator and type it in, because your calculator will give you decimal answers, and I don't want those. I want these, okay? There are a few on here that are a little bit tricky, and not necessarily because I'm trying to be tricky. For example, cosine at pi, number 20. Do we have pi in our chart? No, what's pi the same as? 180. Where did we talk about 180? Page 18. So right now, if you need to use page 18 to help you with something like 18, 19, 20, a few of them that are not in the chart specifically, use that. Next class, we are going to talk about how you use the chart to find anything that is not in the chart but is in the unit circle. Okay? That is all of next class. So just know that there's more than just looking it up on page 18 for those questions. We'll talk about it. Okay? But for now, that's just practice with your chart. Really, that should take you maybe 5 minutes. Okay? I am done.